Good evening, sir.
Evening, sir.
Good evening.
Evening. Good afternoon, students.
Afternoon, sir.
What are you doing?
Afternoon, sir. I'm gonna just say good evening, but I didn't hear you.
You know, so me see you coming in and me say, so wait, she not go tell me Audi. And I wait. And me say, she not tell me Audi.
We say evening, I don't hear you.
But me don't want evening. So when you tell you're evening, you say you're evening them too strong, you know.
All right, sir.
Where Taji then? Taji not come class tonight. All right. So I have I found myself in a little pickle. Today was vetting in St. Anne, and I took down one of my colleagues because he missed the bus. So he had to meet me, and then his car was going to be dropped off at the college. So I had to come back to school. And I did not remember that today is a penultimate day of champs, and that because Excess is so closely located to the National Stadium, I am in the parking lot of the college now with 1, 2, 3 cars visibly. 1, 2, 3 cars. Yeah, 4. So there are 5 cars, my one included, in the parking lot. And I'm just going to do as much class as I feel safe to do it in the parking lot. And then I do the rest in commute. Hopefully the traffic will run off. That's my aim, to run off the traffic. And then see if I can reach home to finish off the session. So
Sir,
let me, yes, no.
you have until about 7 before the traffic runs off.
Yeah, man, yeah. So that's what I just told my wife a while ago, that I'm gonna see if I can stay until about 7:15 thereabout. And then hopefully I can just zoops go home and then I can finish off the class at home. Yeah. So I know I'm gonna be here for about close to an hour, if not an hour. All right. So with that out of the way, I'm feeling very encouraged because there were several exam papers that was required of us to work on today. And we worked on the Calculus 2 paper today. And if you follow my lead, if you do the things that I'm asking of you, if you learn the topics as I teach them, Calculus 2 should not be a problem for you. It really shouldn't be a problem for you. If only you follow my lead, if only you listen to what it is that I'm saying to you, that I want you to be doing, you shouldn't have a problem. Really shouldn't have a problem. But because we know some of them don't listen to me, I'm kind of a little worried. Please, I'm going to ask of you to ensure that you are going through the topics previously covered. Please also ensure that you're completing your EducaSoft. Please also ensure that when you come to the sessions, you come to the sessions alive, ready to learn. Ready to learn. We spent some time today on oh, for I don't teach you that. Because that was calculus. That's not in calculus 2. That's not in calculus 1. We spent some time today this week on volumes of revolution. And I want to start today's session looking at some more examples. I know we were working on a question towards the end of the class, and then I think it was Shamari who sent me an answer. And from my big up Shamari, I say not one more response coming from the group. And I say, I should have just answered Shamari privately and don't say nothing more. Because I am yet to wait, I'm yet to receive a response from you as it relates to the question we're doing in class. Only thing we forget. So that's where I'm going to start. I'm going to start with the homework question I gave you. I'm going to start with the homework question I gave you. How many of you completed the question?
Sir, you're gonna. Me never get the
Mhm.
7, sir. I get 21.
All right. Say it again, Chevy.
I say me never get the 7. Me get 21.
Yeah, but did you give it another attempt though? That's the point. Understandably that you didn't get the 7, but did you give it another attempt? Seeing that I
Me
had
get the
said to
chance.
Shamari, yeah man, pick up the 7. All right, no problem.
Me
And that's
get the
fair.
chance to run through it. Me get the chance to
And,
run back.
and that's fair enough. But guess what? We're getting an opportunity now to go through the stuff. We can't get a question and then turn on and do them. So finish off the question for me, please. I can tell you the answer is going to be 7.5 pi unit cube. That's what Shamari got. And then we're going to be working some questions. If you know what I know, you follow my instruction. That's all I'm going to say to you. If you know what I know, follow my instruction. I want you to finish off that question. I'm going to project another question and another 2 questions. Let's see. But you know what I should have done? No. I'm going to project 2 questions. And yeah, my last 2 questions I have. And these are past paper questions. I'm going to project these and have you complete them for me. I mean, Shamari can start this because he has completed the work. The rest of you need to finish off the homework question I gave before. I'm not joking with you, no. Finish your homework question I gave you before. And Shamari, go through with this question for me, please. It's a May 2019 past paper. I have to leave this car in 2 seconds. I'm going to keep the system running. I hope nobody don't seat and break the car, and I'm right by the security, so hopefully they are still here. Yeah, I'm just going to run out of the car for 2 minutes and come back in. Please to start working, guys. You must complete the work when your teacher gives it to you. All right? I'm going to leave the microphone open in case anybody come in and
That's exactly what I was gonna tell you to do.
yeah. Matter of fact, I think I should turn on the camera too, so in case anybody come in and I can have pictures of who come in here. All right. Give me just half a second. I have to run out. I'll come back in a few. Where's the key? Soon come. All right, guys. I'm back. Um, anybody else finish the question from last class? Shamari, have you started this new question?
Yes, sir. Start with.
Good job. The rest of you, are you still working? Please let me know. Are you still working?
Yes, sir. I'm working on the first one.
Good job. Wanna at least clear the throat now? Because I'm me alone there at school and I feel lonely when I clear the throat now.
Well,
So
no,
sorry,
sir.
that's how it's supposed to work. What you mean if we clear with throat? Me not
Clear your throat. Let me know so I'm not dead there. Cause
understand.
good. Yes, yes.
Sir,
We're there.
focus, sir. John, no.
They are trying match the match, sir.
Listen to me, man. A while ago, me look up and I say to myself, say, then I did daylight a while ago. How it get dark so?
Mhm.
And a long time in the day, excess when it dark so, you know. But anyhow, go on work.
Sir,
Yes, Papa.
but no answer the question there.
Mm-hmm.
For the homework.
Mm-hmm.
Y values, sir. What if my Y values them correct? I'm gonna get 9 and 6.
For the question, the homework question the question that we started in class last time, that's what I'm talking about?
Yeah, yeah.
You get what?
9 and 6. How much you get?
Wasn't the X value -2 and 1?
Yeah.
You get 9? You get the 6, but where you get the 9?
It's a -2, right?
Mm-hmm.
-2 square plus 5.
-2 squared plus 5.
Yeah, 9 that.
A 1 me get for that. Wait.
One of that may get for them
Good
too.
one. Maybe we never. A 1 me get. -2 square is -4 plus 5. You owe 4. You have 5. So you got paid 4 out of the 5. You have 1 left.
-2 square positive 4.
Sure, this is the time when you tell me for right. Huh?
Yes, man. Me a wait for it, you know. Me a wait for it. Me say, here, clear the throat now. All right. So, is this a homework question the question that we had started off in class last time? That's the one.
Yes. Because me the right at the point when me need to integrate and I need to know if me do the right thing.
I get 9 and 6.
All right, me go change my calculator.
Go
This is
figure.
a proven fact.
You got 9 and 6. Chevy.
That's what he said.
Yes, sir,
Well,
I got 9 and 6.
okay, yeah, man. So you're on the right track then. So you can continue now.
So sorry, me change the calculator. Who me go sell it to when me not need it?
Sell? That for throw
Mhm.
away?
No, me not mean that one here. This one is not mine, you know. But I'm just
Oh.
saying. When I buy a Casio
Mm-hmm.
and I'm finished with calculus, I don't think we're doing any other math courses. What do I do with my calculator then?
You can give it to me and I can donate it to a student who is in need.
You wanna buy me one? I'd appreciate it.
I had one and I gave it away to a student who did very well in school, so I do have no more for myself.
We are Jefferson.
That I'm calculatorless.
You can buy me one. And I give it back to you when I finish with it.
Okay, mama. No, this is serious now. So, oh,
Yeah?
so your message no go through all no. Let me just check to see if this is it that for me in a while ago. Your message that I asked to do for me the other day.
What do you mean?
Yeah, me talk to you offline.
Okay, no problem.
Yeah, man.
That's good.
The rest of you, how it stay?
So we're still trying to see how to get 7.5.
Don't try to get my answer. Just work the question. I'll show you how to work it. And you will get the 7.5.
So I tried that, but I got 21.
You got 21. What did you do?
Same, sir. 21 I got as well.
You got 21. What, when you integrated the function, what did you get?
All right, sir. I got y cube over 3 minus 10y square over 2 plus 25y.
And that's where you're wrong.
That is wrong.
Yes, sir. Because remember, you're letting. Remember, you want x squared. When you do the transposition, already you have your x squared. So you're just going to integrate y minus 5. You're integrating y minus 5. So when you integrate y minus 5, you're not going to get a cube. You're going to get square. That is 3. So you're going to let y minus 5 is equal to x squared. And you're going to use that to get your upper and your lower limits. The formula says pi x squared dy. So because you have x squared, let me spotlight it. Because you have x squared in the formulation here, and this is also, did you want square y minus 5? Yes or no?
No, sir.
That means I don't understand where you get cube. Because that means when you integrate y minus 5. When you integrate y minus 5, you can get y squared over 2 minus 5y. Your pi and your upper and your lower limit, your 9 and your 6.
Hold on this, sir. All right. That's based on the previous example, sir. Yeah, the y minus 5 squared.
You can simplify y minus 5 squared.
Yes, on the previous one.
Can somebody confirm that for me, please? Because I don't know what he's talking about. I projected the wrong question to you last time. That's what he's saying. Can somebody confirm, please? What did I project the last time?
All right, just the question, sir. We had like x equal y equal x plus 5, and it gave us 2x value. X equal -2 and x equal 1. Must find the volume around the y-axis.
Mm-hmm.
Hello.
That's what I gave you.
Yeah.
That's what I gave you. And that's correct. But I don't think you're getting the point that I'm making. What is a formula to calculate the volumes generated around the y-axis?
Upper limit. Sir, pi y squared dy.
Pi y squared.
For which one, sir?
When I'm rotating about the y-axis,
X squared dy.
x squared dy.
Yeah, the limit and integral.
All right, so it's x squared dy.
Yeah.
So what it is saying is I need the function in x squared. Now, the equation that was given is y equals x squared plus 5. So because I already have x squared here, I'm going to
Okay.
transpose to make x squared the subject. So I'm going to
Right.
subtract 5 from both sides. I'm going to have y minus 5 equals x squared. So this x squared, I'm going to substitute here for y minus 5. See it here, so?
Okay. Oh, understand now.
Yeah, man. And then I'm going to integrate that. So integrate y minus 5, and you shouldn't get 21 this time. You should get the 7.5.
All right. May I try box?
Oliver, you hear me? Check your chat for me, please, if you are. Well, I didn't even realize that. Okay. What time is it now? 7 o'clock? I don't even want to say it now. Later. You get it now, Simon? Get it now, Chevy?
Hold on, sir.
Sir, I'm not getting it. Not sure what I'm doing.
What function did you integrate?
I didn't. I stopped because I'm confused.
Lady, integrate the function for me, please. I know you know how to integrate. I know you know how to integrate. Go ahead and integrate the function for me, please. Thank you.
What you say, sir?
Integrate the function now.
No, you said something after that.
I know how you know how to integrate, so go ahead and do it for me.
Okay.
Sorry, 7.5.
There you go.
Same, sir.
Very good. Very, very good. Here, Una gone silent again. Yo, Mr. Me alone there. It said, talk to me, no man. Talk to me. Always say with question two. You get to know Astonil?
Sorry, not getting this. Can substitute x squared, but then it doesn't look like something like can work.
Does it look anything like that? Look at the screen, please.
Look like what you had before we say integrate, and I was right there. So I was right at the first step. But then in doing the previous, I was doing as you did the first examples. Remember, you always give us easy something and then give hard things again.
All right, so press pause. Let me answer question to the class. Is this is this question significantly different from the ones that I have been in class? Don't leave me standing.
I
No,
guess we
sir.
agree that it does pose a challenge.
No.
And a little more difficult to figure out. Something.
Maybe because men think different from females.
No, but
Arthur
it's
and I are having an issue.
But you see, in all fairness though, I did the difficult part with you last class. Did I not do this first part with you? Before we do this stuff? Yes or no? Talk truth.
Yes, you did.
I did. So all that is required of you at this stage is seeing x squared is equal to y minus 5. It's to substitute that into the function. I did work out the upper limit and the lower limit for you last class. So everybody should be at this stage
Maybe
for last
because I
class.
was still looking at it to expand the bracket.
And I'm saying no. So that's what I'm saying. It's not in all cases you're going to expand the brackets because you have to look at the function. If the function gives you if the function is in a way that requires you to expand the brackets, you're going to expand the brackets. Sir, how you mean? What do you mean by that? So if you are given a function in only x, say for example, x was only equals to y minus 5, then you'd have had to expand the brackets. But we don't have x, we have x squared. But guess what? It is x squared that I want. So what I don't want you to do, any of you, not just you or utterly, but any of you, is to become stereotyped. What do I mean by that? You only see the question and can do the question when the question come one way. Because that's not how I teach. I teach conceptually. So however the question comes, you should be able to answer because I teach by the concept. I teach conceptually. So see if you can hurry up and finish that one for me, please. Anybody else still working on this? Shamari, finish the other one?
Yes, sir, we get the answer.
All right. All right. What's your answer, Shamari?
540 pi units cube.
Say it again.
540 pi units cube. So let me get the answer.
Yeah, it is not fully what it is that I want. Where am I rotating this one? About the x-axis. So I want the function in y, don't?
Yes, sir.
Good. So you see what I just did a while ago, guys? I look at the axis that I want it in, and then I know it is going to be the other variable. So if I want it in the x-axis, that means I'm gonna have y cubed, y squared. What you got for y? I think that is a problem. What you got for y?
6 minus x over 2.
Correct. When it's squared, what you get?
36 minus 6x plus x squared over 4.
Okay, what is your upper limit?
I think it's 12.
What's the lower limit?
0.
So everything you have told me so far is correct. Now, if you make a mistake, may I come meet up on the road for my lobster, because everything you have so far right. So if I any full mistake you make, may I go squeeze a curry lobster out of you tonight. All right. When you integrate the 36, what you get?
36x.
And when you integrate the negative 6x, what you get?
3x.
When you integrate the negative 6x, what you get?
6x, 3x square. Yeah, that's my problem right there, son.
When you integrate negative 6x, what you get?
So it will be Minus 6x squared over 2.
Very good. What did you have? Positive 6x squared over 2?
No, me have the minus 6x, but me left off the x squared. Me left off the square of x.
Okay. So you had 2 more lines to write in order to get the answer. So have it, just be informed that you owe me and the rest of the people in the class a lobster lunch. Wait name. Lobster Dave just down the road from you.
All
No,
right, sir.
you don't even have to comment on it, you know. Just remember, all right? Anyway, just fix up that for me, please. But I'm very pleased with the with your expansion of the
Sir,
properties. Yes, mommy.
I did something wrong
What happened?
because I didn't get the 7.5.
Okay.
Instead, I got 17.
All right. Work with me now. Are you at this point where you got y squared over 2 minus 5y?
Oh, I see where I did wrong. I didn't put the 6 over the 2.
You didn't put the what?
I got everything else except the third step. I didn't put the 6 over the 2. I skipped that part. Alright, I'm at the corrections.
All right. That's fine. One of the things that I like is for you to discover on your own the errors that we made. So I just went through something with Shamari. I didn't project what it is that he was doing, but I just went through and I kept asking the question, and then he recognized and identified his own error. I think that is effective because you're seeing the things that you are making. I'm going to ask of you, those students. Let me just say this one more time, because based on what I saw today, I'm very encouraged. Already, there are several questions on the exam paper that we can do. As I would have seen, everything that we've done so far is a possible question for your final exam. Every single topic we've done to date is a possibility for your exam in another couple of weeks. You're in a very good light, to the point where I even know the next topic that I'm going to be teaching come next week. And I can tell you, stationary function of multivariable functions, stationary curve of multivariable functions. I'm going to be looking at your stationary points. In calculus 1, we looked at single variable functions. In calculus 2, we're going to be looking at multivariable functions. I'm going to say this once. I don't need to beat up myself. 7:15. I have 2 questions for you. Shamari already is fixing up one, and I have another question that I'm going to share with Shamari. I'm finishing off this topic tonight. I need to start my new topic, which is multivariable functions. I will say this once. I don't think I need to deliberate on this. This topic is a must-have for the final paper. This topic is a must-have for the final paper. When I say must-have, it is being recommended for 30 marks on the exam. The topic that I'm going to teach now, it is being recommended for 30 marks on the final exam. That's all I'm going to say. I don't have nothing more to say to you. That is it. That is it. You get the 7.5 now, Astrid?
No.
Away upon. What are you doing? Where are you now? You said you left out the 2. Look at what I have on the screen now. Tell me if you're there now.
No,
Astrid, what are you doing?
I don't know. Because I got the 81, the 45, the 36, but I'm not coming to get my number to the phone.
You can't get 81 because I don't have 81. I have 81 over 2. And I don't have 36. I have 36 over 2.
I have 81 over 2 minus 45. I have the 36 over 2 minus 30.
Oh, okay, so we can move on then. It's not your fault. It's a calculator. Next.
Sir,
It has to be a calculator issue because you have the correct stuff right here, Aston. If you're saying to me that you have everything here, it has to be a calculator issue.
alright.
Clear your calculator for me. No, you really need to get a calculator. Clear the calculator for me, please.
Clearly.
All right. 81 ABC2 minus 45 equal. Are you seeing?
Minus 4.5. That's the same as under what?
Okay, excellent. Excellent. And then 36 over 2 is the same thing as what?
Minus 4.
So 18. And 18 minus 30 is negative 12. So what you can do now, when I multiply two negative numbers, I get a positive number. So that same negative 4.5 man plus 12, tell me what you get. Negative 4.5 plus 12 equals.
Usually what you have then.
So what's the problem, my love?
7.5.
There you go.
I know the one exactly something like that.
Come on. Shamari, where you get no papa?
144 pi units cube.
All right, very nice. Very nice. The rest of you, can you? All right, hold on. Hold on. I'm proud of you, Shamari. Just continue doing this stuff and you'll be good to go. All right. What I want you to do, Shamari, is I want you to screenshot this question because I want you to move on to this question. And then I'm going to go back to the question that you just did so that the other students can do it. Let me know when you screenshot this question, please.
All right, so I screenshot it.
All right, cool. All right, do one work. All right. Seeing that I have two questions, Shamari's on the second of two, you guys are on the first of two. These are the last questions before I move on. I really want to start that last topic when I am at home very comfortable. So I'm gonna Rockstone. Oh, I'm the only one here now. I'm going to I didn't even see the name. I'm also the power. All right, starting up Betsy. Please, guys, you can. I won't mute the computer. I hope it don't slide off, but let me just try and protect it somehow. All right. I'm gonna be in commute now. Oh, Rockstone. Sorry. I can't be in commute because I'm gonna lose Wi-Fi from here, so I need to go to my hotspot. No. All right. I have a challenge, guys. Oh, I wasn't seeing my phone coming up, but it says connected. All right, so let me get. Can you hear me?
Yes, sir.
Okay.
All right, sir. I'm not hearing you now.
No, man. You're not hearing me?
Yeah, I'm hearing you now, sir.
All right. This hopefully I can read up. Like, I mean, in about 10 minutes from now. Um, If people go to your yards, man. I mean, it's just... But we still.
Sir, I got the 144 now, sir.
Very nice. I'm happy that you get the 144.
What is that, sir? Any cancel the y when you find it, like going to the lowest form, that which would be 6 minus x over 2.
Right. Very good.
I
Very
went
good.
through and did it 12 minus x over 2.
Nice.
All over 2.
Nice. This one I'd agree with is a little difficult because it included some fractional forms. All right. It included some fractional forms, but if you also, if you can't wait, go over my head. They don't know.
You're gonna wait, sir. You're gonna wait.
Sure.
And then I'm hungry about the business. You have nowhere going. I drive up my car when I pay insurance fund. All right. I'm gonna check. I talk to you. So me and them talk. Somebody talk to myself in the car with them, man.
So you were saying something more fractional something?
Oh, sorry. Why are you doing this though?
Cause traffic on the road
Oh.
and you can't stay in a
All right. Yeah. All right. So I was saying that the question becomes a little bit difficult when you have the fractional forms to work with. So Chevy was saying to me just now how it is that he worked it out. So you have to be careful because you see, unlike the one I gave you before, where you had x squared is equal to y minus 5, you had no fractional form. But in this here case, you're going to end up with a fractional form. So you have to make sure that when you multiply a half by half, you get the question wrong. Shamari, do me a favor, please, as I am in commute now. Can you send that question in the WhatsApp group for me, please, that you just screenshot so that Chevy can get it and the others who finish that question can start that for me, please. Hopefully by the time you finish the second question, I'm home.
Sir, this one, it says the x-axis. It means that we're doing it as the same as we did the first one and not as the y-axis.
What this question says, I'm not looking on the computer, what the question says.
Find the volume generated by rotating about the x-axis, the area bounded by x.
Yeah, so you're using the x-axis. So it's going to be y squared.
Okay.
Utterly start working.
Yes, sir.
Simon, it's kind of quiet. Go. If you want to let them go, no, I'm not getting yours up in that street. Ooh, 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 ooh. So you got the question?
Yes, sir.
Okay, cool. Thanks, Shamari.
Yes, sir.
Or we stay? Is that an answer, Shamari?
They're trying to reason it out.
Finish now, sir.
What did you get for the answer? All right, don't tell my answer yet. Put it in the chat for me, please. Put your answer in the chat while the others work on it.
All right.
Cool. Trevor, you finished?
Sir?
Finish?
No, sir, still working. Sir, that one here kind of tricky, sir. I say 3. I say 2x and 1y. Confused. Yeah.
All right, don't worry. I'm almost there. Why you people don't stay home? Jesus, man. Ah. All right, Shamari.
Good.
I'll come in. Shamari, I'm in traffic again, and I just responded to you privately. So look at that for me, please. Yes, is that utterly or Aston? Which one?
That's a new.
What?
The first one. Are we supposed to get a fraction or a whole number?
For the first one?
Mm-hmm.
When is the first one? First one of what? What do you mean?
The one in the x-axis. One I read to you, the x plus the 2y minus 12 equals 0. At the line where x equals 0 and y equals 0.
All right, so let me read a question for you. So it says, and not just for you, but for the whole class. It says a region is enclosed by the curve y equals x squared plus 2. The lines x equals 0 and x equals 2, and the line y equals 2. Find the volume of the
What are you
solid.
reading?
Huh?
What are you reading?
The question.
So the one that we're supposed to do, isn't it the one that's on the screen?
No, we've passed that already.
No,
question?
some of us passed that.
What question are you at? Read your question for me,
Remember
please.
Chevy and the one that's on the screen is what I'm doing. Remember Chevy and Shamari is doing the other one that was sent in the group with the x equal 2 and the y equal 2 with the
Okay, so this
360.
is okay. So this one you're doing the 2019.
Yeah,
Okay, all right. Where are you? I got that from my mobile. I got my y to be equal to negative a half x plus 6. When I do the transposition, when I transpose x plus 2y minus 12 equals 0, x plus 2y minus 12 equals 0.
why we couldn't do it the other way? Like put the 12 and then the x. 12 minus 8.
What do I want to be the subject? What do I want to be the subject of the formula?
Why?
Good job. So any way you want to put it, as long as you get y to be the subject of the formula, you're good to go. Anywhere you put it, just give me y the subject of the formula.
Yeah, but then I have 12 minus 8 over 2.
You can't have same difference. 12 minus x over 2 is the same difference.
1 and
12
6.
minus x is the same difference. So go ahead. So you yeah, 12 minus x. Okay. So use your 12 minus x times 12 minus x, 12 minus x over 2 times 12 minus x over 2 until multiply. 12 minus x. Yeah. So use it 12 minus x times 12 minus x over 2 and tell me what you get.
Hold on a second, sir.
I think we have too many cars in Jamaica.
So I multiply it and I expand the bracket,
Mhm.
right? And I got 144 minus 12x over 2, and then 12x minus x squared over 2.
When you'd have done your expansion, you're supposed to be left with something like a quarter x squared minus 6x plus 36. However you want to write it, you can have 36 written first, however you want to write it. What Shamari gave me was 36 minus 6x plus a quarter x squared. Doesn't mean anything to me. However you write it, that's what you're supposed to get. Get that?
No, I don't get that. I'm gonna do it over.
You don't need to do it over. Just do the multiplication for me, please. When you're multiplying the 2 times the 2, you're multiplying, oh Lord, what you told me.
So the
12x
numerator is, the denominator is supposed to be multiplied as well, is what you're saying.
supposed to work out to be 4, don't?
So I didn't multiply the denominator.
You don't have to do over anything. Just go ahead and just do the multiplication. As in here, more if you get over this fear of you doing something and it don't look right to you, just continue working, man. Don't start over anything. What you have is correct. Just go ahead and do the multiplication out for me, please. Do the multiplication from that side. And that's why I didn't want to multiply it as a fraction. How do I help you with this one? All right, do me a favor. I don't want you to multiply it as a fraction because I think that is confusing you. So what I want you to do is to go and say what you gave me was 12 minus x over 2. Put the 12 over 2 minus the x over 2, and the 12 over 2 can give you 6 minus x over 2, which is exactly what Shamari has. So use 6 minus x over 2 times 6 minus x over 2, and the multiplication should come easier for you like that.
Use 12 over 2 minus x over 3, you said?
No, ma'am. You told me you have 12 minus x over 2.
Yeah, so y
Yes, no?
equals 12 minus x over 2 is what I have.
And all I'm saying, all right, I am home. Just give me 2 minutes. Let me just go plug in my thing, please. I'll come in. Just give me 2 minutes. Let me do it for you. Figure out anything further? Or you still at the same place?
I'm at, a quarter x minus 3x, expanding the bracket, minus 3x plus 36.
Oh, so you're able to move on?
Yeah, I, I,
Uh,
I put it the other way
so
than as how you did it and multiplied with
36.
the
I hear you say
fraction.
something. Say it again?
You hearing me?
No, sorry, you're breaking up. I'm hearing you now.
I was saying, hold a second,
Oh,
sir.
it's my internet that is unstable. Oh,
It's
hold
mine.
on.
It's
No, hold
mine.
on, hold on, hold on. Hold on, hold on, hold on. No, it's mine. No, man, it's mine. Uh, All right. No, it was mine. Remember, I was hotspotting from my phone. So I just switch over to the Wi-Fi now. Go ahead.
I was saying, I'm at expanding the bracket.
Give me the brackets.
So I've got the starting bracket
Yeah.
minus a half x plus 6 times minus a half x plus 6.
Oh, see right here, so right here. Right here.
That's what I was saying. I'd put it your way and multiplying by the fraction.
Mm-hmm. What is negative a half times negative a half?
A quarter.
Very good.
And then we bring back the x.
So you get x squared, good. And then negative a half, x times 6. A half of 6 is 3, so that means it be negative 3x.
Negative 3
Good. And the same thing here, negative 3x. And
plus
6 times 6 is
36.
36. So this is a standalone, negative a quarter x is a standalone, so I write it back. And negative 3x minus 3x is negative 6x. And then I write back my 36. And that's what I'm going to integrate now. I'm integrating all of this. What I do is I rearrange something here first.
But sir, I got the same 144 earlier, I know, except I got it with as a fraction. So I had 144 over 2.
But that's not the same
Make
answer.
it incorrect. I'm just saying.
Right. Yeah. 144
Um,
is the same.
oh, you got the 12 to be the upper limit?
That's from way up here.
So we just leave it at that?
No, to me, leave it like that.
No, as in when we substitute right here, right? With evaluating for the y.
Mm-hmm.
That's what I didn't know we were using that as limit.
What are you talking about, Asunu? Tell me what you're talking
I
about.
guess I wouldn't be able to move from the quarters x squared. Because I got the 12, but then I didn't think of using the 12 as the upper limit.
You got the 12?
Hmm?
You got the 12?
Yeah, but I wasn't thinking of using
What
the
else? What else did you get?
0.
Okay, so what is the upper limit then? 12 or 0? Which one is
12,
upper?
12 would be upper.
Absolutely. So it has to be the 12, the upper limit. So the bigger of the two is going to be the upper limit, and the smaller of the two is going to be the lower limit. But remember, you're rotating about the x-axis. So x there is going to be, remember, it's the value of x you want, but you're given one of the x's to be equal to 0. So you want this value. You want this value x equals 0 because you're rotating about the x-axis. So you want this value x equals 0. This is the value you don't want, y equals 0, because you're not rotating about the y-axis. So since you don't want this y equals 0, that's what you're substituting into the function. So this here goes to 0. And then you're going to have x minus 12 equals 0, x is equals to 12. Remember, you have to work out the limits of the function. If the limits of the function is incorrect, best believe everything else is going to be incorrect. All right, let us quick and fast with this stuff now because I was hoping to start the other topic by 8, but never mind. So when I rearrange right here, I rearrange right here. And when I rearrange it, I thought, like, not there. I rearrange right there. So what it is that I did, I put the 36 in front. So when I integrate 36, it becomes 36x. When I integrate negative 6x, it becomes negative 6x over 2. And when I integrate negative a quarter x squared, or sorry, a quarter x squared, I'm adding 1 to the power divided by the new power. Watch how this comes about. It's a quarter x squared. I'm adding 1 to the power, dividing by the new power. The new power is 3. X times 1 is x, so this is x to the third power, and 4 times 3 is 12. So I'm going to get x cubed over 12. Get me?
Yes, sir, I'm following.
Okay. And then now my integration would have been finished. So it's always going to be the upper limit minus the lower limit. So the lower limit is going to be 0 because all of these terms contain a 0. All of these terms contain a 0. So I'm going to substitute 12 into the function. So I'm going to have 36 times 12 minus 6 times 12 squares. I did something wrong here. I left off the 2 right here. And what is all that? Plus x cubed, and x is 12, so it's 12 cubed over 12. And evaluate that for me, please. And I think I left off the 2 right here. Yeah, I did. Or if I'm going to do that, I should have written 3. Yeah, so all of that works out to be 144 pi x cubed.
So, sir, if you have left off the 2, would it still be the same answer?
No, ma'am. If I leave out the 2, I'm supposed to move that 6 no to
Bring it
3.
back. Okay.
I need to move it to 3. All right, Shamari. Shamari, very good. I'm proud of you. Chevy, you know, say now going good tonight.
I'll go on, sir.
Me not hear from you. It's like you drop asleep.
No, mom, there, I'm on, sir.
But you you stay with the second question. What's the answer?
Sir, I just work with the X's, you know, sir. And work with the Y. I work with the Y, I get 0.
So what is your answer?
Get 25 and 1 over 15 by units cube.
Very nice. Proud of you, Papa. Very good. Excellent. Simon, what say you?
So I don't reach that far.
Hey, Simon. Hey, Simon. Simon, I'm going to call Peter and talk to him. Oliver, Augustine. Arthur Lee, Augustine.
I'm taking my work it, my brain kind of.
Asleep, you asleep. Asleep, you asleep.
I'm not sleeping, sir. I just was eating and I'm working, but my brain
Arthur Lee?
tired. I know.
Arthur Lee,
Sir?
I'm going to hold you and squeeze you through the
No,
computer.
sir, you don't have to do that.
All right, then.
I'm working,
hoping.
sir.
Okay, I'm hoping. All right. I just get a feeling that there's only 2 students understanding this topic. And part of the problem is there's nothing wrong with the topic. You know, part of the problem is foundational stuff that I'm missing in terms of you expanding your parentheses. It's foundational stuff, and it has what it is that you're having a difficulty with has nothing to do with calculus 2. Has nothing to do with calculus 2. Nothing to do with calculus 2. Oh my God. How is Steve? Talk to me. I have to get in a little bit of other topics. I need to know where you are. You know, part of the problem, I won't say it.
Sir,
Go ahead, Alpali.
Asaniel.
Also, Aslan.
I don't think I'm okay with the topic.
Mhm.
Because when I expand the bracket, so in the first half when doing them, I made a mistake by canceling out when I shouldn't have.
Mhm.
But I'm fine with expanding my brackets.
Mhm.
I think where I have the problem is, I think right after the integration, oftentimes I'm just stuck there for a while.
That's the easy part because already right you're substituting.
And then when the limits are not given, I feel like I have a problem finding it.
Well, you're going to have a problem because sometimes they don't give you the limits. And that's why the question can come for 10 marks and 50 marks. Increasing the complexity of the question when you have the more information you have to find in order to work the question is a more marks the question is worth. So you have to go and get with it. They may give you the limits, you know. They may. I don't know. They may give you the limits, but they also may not give you the limits. And now it's going to be up to you to decipher which is which, what is what, how it is that I'm going to be working the question. It's up to you, you know. But yeah, this one is a must have. It's one of them that loves to show itself. So I was going to say something. I think part of the difficulty that we're experiencing, and I'm gonna make that notation. As I told you, I'm gonna come to you for, you know, with some interview questions, you know, the first set of students doing block scheduling, you know, if it was beneficial and how it is that you're understanding, etc., etc. You know, if you do another block scheduling course, you know, some of the things that I'll ask. But let me tell you what I find. Because of the nature of the course, the block scheduling, as opposed to calculus one, where we had enough time to digest the stuff. Compared to now, we are still given the required number of hours to complete the course, but the time for digestion is half. But when I give you homework, you just don't do the homework. I will waste a lot of time doing the homework in class. We waste a lot of time doing that. And if you don't put up your socks, you're going to fail. You're going to fail. So when you don't do your homework, let me tell you how I translate it. And I may be wrong, but let me tell you how I translate it. You're not opening your maths book to do the work. Because if you open your maths book to do the work, you would have seen that question. Some of you don't even open the recording. So I'm saying to my students, I'm saying to you, bro, not shame me. Open a book, start working. If it's not difficult, it can be done. Understood?
Yes, sir.
Mhm. All right. So you end up with the 144 now, Astonil?
Yes, sir.
Good. Simon, did you get the 144?
Yes, sir.
Good. Utterly, you got it?
I can finish it.
Um, Oliver, or you stay? All righty then. This is now 20 past. This is 20 minutes past the hour. All right. I want your undivided attention. The topic that I'm going to be doing next is building for my full 30 marker. I'm building for my full 30 marker. I need your undivided attention, please. All right, so I'm going to be talking about some multivariable function. I'm not even going to teach you how I'm not going to teach a topic. Because I kind of see the script so gone, you know. And me not gonna get worried about No exam business. So if I give you f of xy to be equal to say 2x cubed plus 4xy plus x plus y. Want to work with me?
Sir, me still answer the question what I'm just working across.
All right. Well, you look in another 2 seconds and see if you see the correct something now.
Yes, sir, seeing it now.
Mhm. So we're looking at our multivariable function. Trying to work with me. I have a function and it's called multivariable because the function is consisting of both x and y. Can you agree that the function has both x and y in it?
Yes, sir.
So it's called a multivariable function. The ones, the stationary points that we did in calculus 1, it's really single variable function because guess what? It's only x alone we have in the function. F of x is equals to a function in x. But for this one here now, we have both x and y. So it's going to call a multivariable function. And incidentally, let me see. I can give you a function as your syllabus requires for x, y, and z. I can give you a function that is going to be in x, y, and z. So therefore, I want you to work with me. I don't want anybody to blink. Look at the screen. I'm going to go through very slowly. If you're not seeing something, ask me. Let's go. The function is f of xy is equal to 2x cubed plus 4xy plus x plus y. It's a multivariable function. I'm going to be doing my first order partial derivative. My first order partial derivative. I'm going to call my FODE. My first order partial derivative. My first order partial derivative. Watch me. My f subscript x of xy. My first order partial derivative with respect to x. That's why I have a subscript there as x. My first order partial derivative of the function with respect to x. It means that I'm differentiating x. Everything else is going to be a constant, and the differential of a constant equals
0.
0. So when I differentiate 2x cubed, I'm going to get 6x squared. Do you agree with that?
Yes, sir.
Yes, sir.
Watch me now. This y is a constant. However, the y is married to the 4x. I cannot throw it out as it is. So when I differentiate that, I'm just going to differentiate my 4x. I'm only now differentiating my 4x. When I differentiate 4x, what do I get?
4.
4.
So I'm differentiating what I want, and then I'm going to put back the y. Why, sir? Because my y is a constant. I'm going to put back my y there. I'm not differentiating it. I'm going to put it back. When I differentiate x, what do I get?
Yeah.
1.
1.
1. And when I differentiate y, what do I get?
1.
When I differentiate y, I get what?
Why?
dy by dx.
No, that is implicit. I was hoping that somebody would have said that, so I can say implicit. When I circle this one, I was hoping that you didn't say implicit. No, but remember, no, which one is a constant again?
The y,
The y. So when I differentiate this, what I'm going to get?
0.
0. So remember that y is a constant in this particular case. So when I differentiate y, I'm going to get 0. Now I'm going to show you something. I want to prove something for you. 4xy. I'm calling my 4x the first, and I'm calling this one the second. Now, when I'm differentiating as, you know, obviously the first times the differential of the second plus the second times the differentiation of the first, right? So the first, 4x, remember I'm differentiating with respect to x. So everything else is going to be constant. So the first, 4x times the differential of the second. When I differentiate y with respect to x, it becomes
Constant.
0. So it's going to be 0. Plus the second, which is y, times the differentiation of the first. When I differentiate 4x, I get 4. So this goes to 0. So I'm left with 4y. So what it is that I'm doing is just a shortcut method to show you how to do the first order partial derivative of 4xy. I just did it the method that we learned in calculus 1, the first times the differential of the second plus the second times the differentiation of the first, and we end up with the same answer. It's the same thing, but I'm now showing a shortcut method to do the partials. These are partial derivatives. Partial because I'm not doing a full differentiation. I'm only differentiating piece by piece. All right. So that's my partial for x. Watch me now. I'm doing the partials for y. Don't blink. I'm differentiating with respect to y. So anything in x is going to be a constant. And when I differentiate a constant, I get 0. So what's the differential of 2x cubed with respect to y?
X0 squared.
0. Very good. It's going to be 0. And then now I'm differentiating 4xy. The 4x is a constant, so I'm going to write it back. And when I differentiate y, I'm going to get 1. So it's just going to be 4x. When I differentiate x with respect to y, I get
0.
0. And when I differentiate y, I get
1.
that's it. So that's my first order partial derivative. Any questions?
Can you go through it again, please?
My pleasure. So I'm giving you my function. F of xy is equal to 2x cubed plus 4xy plus x plus y. I'm doing my first order partial derivative, FODE. And my first orders will be me differentiating the function with respect to x. Since I'm differentiating with respect to this x, everything else is going to be a constant. It means, when I say everything, it means that the y is going to be a constant. It means that the y is going to be a constant. So what I'm going to do is differentiate my function. So I'm really looking forward to differentiating my x. When I differentiate 2x cubed, I'm going to get 2 times 3, 6, 6x squared. That first term is done. When I'm differentiating 4xy, it means that my y here is a constant. And it's a multiple of x and y, but my y is a constant. So because it's a constant, I'm going to put it back. I just write it back as it is. And then I'm going to differentiate now my 4x. And when I differentiate the 4x, I'm going to get 4. So it now becomes 4y. So the differential of this piece here is going to be 4y. And see, I did it here. 4xy. 4xy. What I did was to call my 4x the first and my y the second. So it's the first, which is 4x, times the differentiation of the second. When I differentiate y, I get 0. Why, sir? Because I'm differentiating with respect to x. So it means that y is going to be equal to 0. Plus the second, which is plus y, times the differentiation of the first. When I differentiate 4x, I'm going to get 4. Now 0 times anything is 0. I'm going to put my y by 4, I'm going to get 4y.
So that look like one, you know, sir. That's okay.
That one? All right, let me fix it for you. Oopsie daisy. All right, so that is that. Now, let me look at my second order partial derivative. My second order partial derivative would be something like f of xx, xy. You know, like when we're doing differentiation, I ask to find the second derivative, and then I say to find the third derivative. So the second derivative would be dx squared over dy squared over dx squared. In partials, is when I have the xx or yy or xy or yx. Boy, students, I'm going to tell you the honest truth. And I can only speak the truth. Now that I'm home, the sleep is on me. Do me a favor. Let us agree for tonight. No, I know, wait, stop. No, don't think that I'm going to say I'm in class, no, you know. Nope. Because it's going to come out to bite me. Just saying to you that the sleep really turn up. I've been on the road from morning doing the school business. And as you know, I just came in because I went back to school. I'm going to do the second order partial derivative. I'm going to entertain your questions. Then I'm going to give you one to do for me. And when we complete that one, we'll call it the end of the class for tonight. Fair enough?
Yes, sir.
All right. Because really and truly, I'm actually fighting. I'm actually fighting sleep now. I was fine all along at school. But I guess the tiredness just kind of come down now. All right. So my second order partial derivative is going to be finding the second derivative. Now, to find the second order partial derivative, fxx, f subscript xx. In order to do xx, I will have to start from f subscript x. Remember, when you're finding the second derivative of a function, we have to find the first derivative first. We can't just jump and find the second derivative without finding the first. So we normally find the first derivative and then differentiate the first derivative one more time to get the second derivative. Differentiate it one more time to get the second derivative. So therefore, in order to find fxx of xy, I'm going to differentiate the first order partial derivative with respect to x one more time with respect to x. So I am differentiating this piece here, this one here. See, in order for me to get that, I have to first look for this, which is that function there. And then I'm going to differentiate it with respect to another x. So the x outside there tells me what to differentiate it with respect to. So when I differentiate 6x squared, what do I get?
12x.
And when I differentiate 4y, I get? So 0. 0, because remember, I'm differentiating with respect to x. And when I differentiate 1, I get?
0.
I get 0. Very good. Now, my second order partial derivative of f of yy, xy, it means that I'm going to be differentiating f of y is using that equation. So therefore, I'm going to be, and I'm differentiating with respect to y. Uh-oh, what do I get for my answer?
0.
0. Very good. Why 0, sir? Because I have a 4x. That is not y. So that 4x becomes a constant. And then I have a plus 1. That is not y. So I'm going to get a constant 0. All right. And then what I can have is a cross order Yeah. All right, so nobody. What I say FODE is
First order.
first order what?
Partial derivative.
Is that correct, sir?
It's supposed to be first order partial derivative.
Never put the P.
Me did ask you, sir, but then me say, no,
No,
man, you know what I'm gonna do.
I just laughed to myself when I look at this. I like, what is FODE? I was like, what the heck?
They do the same for SOPE.
Right.
But you tell us you don't blink.
Good. And now that you see it, I can tell you that I'm really tired now. All right. So the first order partial derivative and then the second order partial derivative. I only saw it when I glance at it when I'm looking at the cross order partial derivative. All right. So my cross order partial, my cross order COPD. You know that COPD is a sickness, don't Jesus. Don't remember what it means. But anyway, my cross order partial derivative is when I'm evaluating things like f of xy and f of yx. That's what the cross order partial derivative. And if you recognize, look here, so you recognize that I have two something here, so, and two something here, so, and two something here, so, and two something here, so, because the cross order partial derivative is really a second order derivative as well. How you know second? Because there's two things on here. How you know that this is first? Because there's one thing down here, so. So whenever you get a first order partial derivative, is one variable you're differentiating with respect to either x or y. When you're doing a second order partial derivative, you're finding either xx or yy. When you're doing a cross order partial derivative, you're finding an xy or a yx. There is a special story about xy and a yx, but I'll allow her to introduce herself. Very nice person, but I'll allow her to introduce herself to you momentarily. My cross-order partial derivatives are done in a similar manner. My cross-order partial derivatives are done in a similar manner to what it is that we've been doing. How similar, sir? Thank you for asking. I am going to be looking at my f subscript x. I'm going to be looking at my f subscript x, and then I'm going to differentiate it with respect to y. Then I'm going to differentiate it with respect to y. So when I differentiate my f subscript x with respect to y, 6x squared becomes?
Zero.
Very good. And my 4y becomes?
4.
4.
And my 1 becomes?
0.
Excellent. Similarly, this one, I'm going to be looking at my function f subscript y of xy, and then differentiate it with respect to x. When I do that, tell me what I get.
0.
4.
I get 4.
4.
Do you agree that I get 4?
Yes, sir.
Has my friend introduced herself to you yet? What are you seeing with her?
Values are the same.
She's she's equal. She's real. So once it is that you would have calculated your first order partial derivative and second order partial derivatives correctly, it simply means then that when you're calculating your cross order partial derivatives, both cross order partial derivatives must be the same. If your cross order partial derivatives are different, it means that you did something wrong, either for the first order or second order calculation. Let me say it one more time. Whenever you calculate your cross order partial derivatives, your cross order partial derivatives will be f subscript xy or f subscript yx. They both must be the same value. If after calculation, you're getting a different value for the cross order there, partial derivatives. Say you get 4, it is wrong. They must come out with the same value. Fair enough?
Yes, sir.
All right. That's where I plan to stop for today. No, yeah, that's where I plan to stop for today with the teaching. I am now going to be asking you if, no, and I'm going to ask you. I'm going to give you 2 minutes to look through the question, the solution to what I just did. And I'm going to ask you to write down your concerns, questions that you may have. And then once I would have answered those questions, I'm going to give you one of these same questions to do. All
Can you
right?
zoom out so we can take a full look, please?
Absolutely. There you go. Big in 2 minutes.
Thank you. So does these questions come in fraction form? Sharika,
Obviously, any questions?
does these questions come in fraction form?
No, I don't. You won't get the fraction form up here. So sometimes when you work when you differentiate it and trying to do something else in the second half of what I'm going to teach you, you may get a fractional form, but don't worry about that part yet. What I'm doing with you is just split in stages. And the first stage would do these 6 calculations. F subscript X, F subscript XX, F subscript Y, F subscript YY, F subscript XY, F subscript YX. Those 6 calculations in and of itself, give you 5 marks. Those 6 calculations in and of itself will give you 5 marks. Just like that. So out of your 30 marks, doing those 6 calculations correctly, you have 5 marks already. So why not 6? Because I recognize that f subscript x, y is the same thing as y, x. So let us give you 1 mark. Then, sir, we can only do one of the calculations. No, do both. Because when you do both, it tells you, if you get the same answer, it tells you that your other questions or solutions up top are correct. If when you do the f of x, y, and f of y, x, and get a different value, press pause, start the question over from scratch. All right? Now,
Sir,
yes, Papa.
just to understand it more clearly, when we differentiate for x, that the f of x, the f for x, right? We just say that y is a constant, and when we're doing f of y, then x is the constant.
Very nice, son. Excellent. So once you're differentiating x with respect to x, it means that the other one, y, is a constant. And when you differentiate a constant, you get 0. And I'm differentiating with respect to y, x is a constant. Do that one for me, please. Finish?
No, sir.
Yes, I. All right, talk to me. What is it that I got? Anybody finished?
Let me try something, sir.
All right, and that's always the attitude. If it is wrong, But she
Mhm.
said 4, we're going to go again. All right, so I'm going to move into the solution of this now. F subscript x of xy, what do I get? Mm,
Y plus 4x.
very good,
Why? 4x.
very good, excellent. Anybody else see that?
Yes, sir. We get 1 point.
Sir.
Yes, Simon. Did you get it, Simon?
Yes, sir.
Good job.
X plus 1 for the next one.
S subscript y of xy is equals to what?
X plus 1.
Everybody agree with that?
That correct, sir?
Yes, sir.
That's what I have, you know, sir.
Yes, correct. All right. What do you get for f of x, y now?
4. Man. What?
Hmm?
4.
4x.
4, sir.
4, not x, Astenil 4.
Sure, so harsh look at me.
I'm not shouting. I'm just talking strong. I'm just talking very strong. 4. Let me say C.
Yeah, see.
All right. F subscript y.
0.
You sure about that?
Yeah.
Astenil, do you agree with Ottilie? She said 0.
If I get 4x, then I guess it would be 0. But then it says it's not 4x, it's 4.
What's the answer for that one, Astenil? For f of y. I'm differentiating f subscript y with respect to y again. What do I get? Talk to me, mommy.
0.
Okay, thank you. I'm gonna get 0. I'm gonna get 0. Everybody's got the 0?
No, sir, I
Yeah.
get 1.
Why you get 1?
I get 0, sir.
Tell me why you get 1, Shamari. Very good, Chevy. Tell me, Shamari, why I got 1. Remember, I'm differentiating x with respect to y. So that goes to 0. And I'm differentiating 1 with respect to y. That goes to 0. Because those are constants. You see it now?
Yes, sir.
So
All right.
hold on then, hold on.
Mhm.
What you have on the left hand side, where you have y plus 4x, that's what? The first order partial?
For x, yeah. No. Yeah, the first order partial is up
Are you
there. So
doing them across?
yeah.
Okay.
Mhm. Cross order partial now for f subscript xy of xy. I'm differentiating y with respect to f of f subscript x. What do I get for that?
0.
Think about it.
4.
With 1 R4, sir.
I'm differentiating that, which is this, with respect to y. What do I get?
So 1.
1. Because the 4x is going to be a constant, which is 0. So it has no y there. I'm going to differentiate y, I'm going to get 1. What is f subscript y x now? Xy. I'm differentiating, I'm looking for f subscript y, which is up here. I'm differentiating with respect to x. What do I get?
1.
1. When I differentiate x, I get 1.
Yes. X.
Right. And when I differentiate 1, I get 0.
Yes, sir. 0 plus 1.
All right. I am done for dear tonight, but I just want to take me back about a minute and say something to you. There are 2 students who have completed their EducaSoft. When I said completed, completed with perfect scores. There are some of you here who need to start. Just like for those who did Calculus 1, the exam went on a Friday. And by the Monday, I was ready for submitting my grades. I had 2 scripts that I had to peruse. And it took me an extra day and a half just to make sure that what it is that I'm doing is okay. So by Wednesday, your final grade was submitted. Don't know what the hold-up was, why it is that you weren't seeing it, but by Wednesday morning, the final grade was submitted. What's the point I'm making? Similar to Calculus 1, when the exam would have gone, I am going to use a couple of days to mark off your exam and get it out of the way. Where EducaSoft is not completed, you're going to get zeros. You're going to get zeros. My final thing is, a number of you, so I'm speaking to the converted, but just remember, in all things, not just with math, but whenever you miss a class, you're missing instruction. And I'm not talking about you oversleeping and can't come to class, you know. That's not what I'm talking about. I'm talking about when you consistently miss class. Either 1 class of the week, or you miss a whole 3 classes of the week. When you miss class, you miss instruction. Yes, you can access the recordings asynchronously, and you can learn. I agree with that. But I know that is not happening either, because I can look at the analytics of the videos. Some videos go, and not one student cut them. But they still come to class. Sir, can you upload the videos, please? Sir, can you upload the video? Can I upload? And then I look at them. I go and I look at the analytics and it 0 views. Some of them 1 view. And every day come back, sir, I was looking for the, I'm not seeing this. Can you upload it? Can I answer?
So I talk my own voice, because that sound like a mimic me.
But sure, no. You see, what Jesus, I'm speaking generally, no, but if you want to take it, that's fine. But I'm just saying to the students, I believe in you. I believe in every single one of you. It's when you're done my class, I give you permission to see my road and don't have to call to me. Me will see and say, yes, my student that. But I want you to pass. I really want the best of you. Some of you are not pulling your weight. And if you allow the course to run too far ahead of you, you are not going to pass it. So when I come to class and I give you work, work. If you're not understanding something, pause me and ask me to go through. I will never get annoyed at you. If you say, Lord, you can't understand something, that's not me. So you have to make sure that you do what is so required of you. Some of you are just existing on a Monday, Wednesday, and Friday. And we need to come good and proper next week. See, we'll have class on Monday, we'll have class on Wednesday, but Friday coming is Good Friday, there's no class. And the other class is going to be.
Sir, I don't feel comfortable asking questions in class. I can
Say
see
it,
students. I don't like to do it.
say it again.
I don't feel comfortable asking questions, especially when I feel like I'm holding back the class. I don't like to do it. Sir.
Utterly, let me tell you, say you hold back the class. You don't take that position. Let me tell you, say utterly you're holding up the class. So you ask me a question, me I give you permission for asking me a question. You don't tell me, you don't feel like you holding up the class. Let me tell you, say you hold up the class, and you'll never hear that from me. You ask me, Otterly. Me, I give you permission to ask me. All right? Please ask me. So we're missing a class next week, Friday, because of Good Friday. And we're going to be missing a class on Monday, Easter Monday. So we're missing 3 plus 2, we're missing 5 hours. I am going to patiently watch Edicosol to see if those 5 hours are going to be used to complete your assigned tasks. But on a serious note, though, finally, on a serious note, you all have the propensity to pass, but some of you, if you don't pull up your socks, will either get a resit or you're going to fail because you're not putting enough into it. And when I was working and going to school, like on a Friday evening, 4 o'clock to 7 o'clock, I would have had a class. My class on a Friday evening ended at 5 o'clock. So when I rush go class, and this wasn't online, when I rush go class, sometimes I'm reaching class 5:30 minutes to 6. Class done 7 o'clock. You have to get home, put a plan in action, and study. Practice the questions. Go through the recordings. If you not do this, guys, trust me, not gonna work out. But do have yourselves a wonderful rest of the evening and weekend. And come bright and early Monday, Wednesday. We're going to see how best we can continue working on the multivariable functions. There's so much more to it than what it is that we've done. I will see if I can concretize the first order, second order, and cross order partial derivatives so that you can understand it, so we can pick up those 5 marks. Remember, a question on your multivariable function, stationary points of your multivariable function will carry 30 marks on the exam. And once you get those 30 marks on the exam, you already pass the course. All you need to do is just to find another 30 marks and then you can get your A. Big up on yourself. We'll talk later.
Sir. Enjoy your weekend.
To you too, Papa.
Have a good one, sir.
You too, my love. Later.
Mm.